Today, this seminar will examine the most common wood framing and sheathing errors found in construction today, provide practical solutions for avoiding them. Topics of discussion will include buckled sheathing, squeaky floors, check beams, oversized holes, connections, do's and don'ts. Findings and discussion will be based on hundreds of job site inspections performed by APA, the Engineered Wood Association. Geared for structural engineers, this session will provide attendees with the tools to avoid these costly mistakes and ways to correct them. First, a little background on the APA. APA is a nonprofit trade association that is involved in the quality assurance and production promotion of most engineered wood products that are manufactured in North America. Originally named the American Plywood Association, APA initially focused on softwood plywood. However, as more engineered wood products came into the marketplace, APA's focus expanded to include oriented strand board, glued laminated beams, I-joists, rimboard, laminated veneer lumber, and other types of structural composite lumber products, and became more formally known as APA, the Engineered Wood Association. The APA is made up of four primary divisions. The Quality Service Division tests and inspects products during manufacturing processes. The Technical Service Division works in product and system research and application and building code development and actively helps users and specifiers to better understand and apply these products through their APA help desk services. The Market Communications Division is responsible for communicating APA information, including the development and maintenance of APA publications, as well as our website. The APA website, www.apawood.org, contains hundreds of APA publications geared towards the engineered wood industry. And lastly, the Field Service Division serves the building industry by providing local in-market support to design professionals, builders, and code officials in the proper use and specification of engineered wood products. The Field Service Division provides in-market support across the United States and Canada. We're currently staffed in all markets shown on the map in red, and we are in the process of filling positions in Florida and Denver. Your local field contacts can be found on our website, apawood.org webpage. So to better understand the challenges and opportunities with engineered wood, we need to understand a few basic concepts. So in this seminar, we're going to look at the big idea. We're going to look that wood has a strength direction. We're going to talk about how wood moves. We're going to talk about the importance of consistency of construction and how that counts. We're going to take a brief look at moisture intrusion. And lastly, we're going to talk about load path continuity through the structure. So let's first look at wood as a structural member. Here are some of the APA founding members exhibiting the strength of a plywood panel in bending. Bending is a product that's typically reflected in its deflection and the allowable bending moment of the material. So let's first understand that wood has a strength direction. Here is a classic example to illustrate the strength of wood according to its grain. Wood is primarily made up of parallel tubular structures. So on a microscopic level, we can model wood behaving like a bundle of straws. When compression is applied parallel to the grain, the straw bundle is strong and efficient, resists crushing and tensile loads. If the load is applied perpendicular to the length of the straws, or perpendicular to the grain, the straws crush more easily. This is similar to wood, since the lower force is required to cause this crushing failure, perpendicular to the grain. This illustrates the anisotropic nature of wood, different strength properties in the three different directions: longitudinal, strong; tangential, weak; and radial, weaker. Plywood layers are oriented to provide strength in two directions. As we saw in the straw example, wood is strongest parallel to grain. Plywood is constructed by cross-laminating an odd number of layers made up of wood veneers that have impressed so that all the wood grains are not oriented in the same direction. By alternating the grain direction in each layer, the strength and stiffness is maximized in both directions, but generally stronger in the long direction of the panel. Similarly, oriented strand board is composed of compressed strands arranged in layers that are oriented right angles to one another. This orientation of the layers achieves the same advantage as cross-laminating the veneers in plywood. Again, since wood is strongest parallel to grain, the orientation of the compressed strands distributes the natural strength of the wood in both directions. So with this understanding, we know that there are some guidelines to be followed to install sheathing correctly. One installation criteria is that sheathing is not intended to be installed as a simple span. Sheathing deflection calculations are based on panel spanning a minimum of two spans or three supports. This is a common misinstallation application wherein a framer can finish out an area with a simply supported span panel, or sometimes happen in areas of repair where the patch may be installed as a simple span. This can result in a soft spot in the floor where possible excessive deflection can then impact the floor finishes.